In this video, we are again looking at the relationship between blood flow and, in this case, vessel length. And so we're going to use an app that has that relationship and allows us to collect some data. So here's my app. And at the beginning of this, it says set the pressure to 100, which I've already done. Radius to 3. Viscosity is supposed to be here at 3.5. And keep these 3 constant. All right, so got that. And this time I'm changing vessel length. So I'm starting with vessel length at 10. And I want to go to the length tab to see the graph of this. And I see that it is definitely decreasing. There's a curvature to that as well. And so when the vessel length is 10, I read up here the flow rate of 90.8818. And then next I'll be changing vessel length to 20. And so when I change it to 20, I see the flow rate decreases pretty dramatically there down to 45.44. And so I'm going to go through and do all of these, and I'm going to record my data here on my PowerPoint. So I have done these ahead of time, and I am going to just take time to write them in so that we can look at our data. So this first one we did together is 90.8818. Next one we did together was 45.4409. And then ones that I had previously done, this one is 30.2939. This one is 22.7204. And the final one is 18.1764. So we have our first question, which is the length of the blood vessel changes over the lifespan, and since have shorter blood vessels than adults, how does an increase in length impact blood flow? So increase in length would be, as I move down the chart from 10, 20, 30 up through, impact on flow, flow will decrease. Next question, what is varying? Well, my 2 columns are vessel length and blood flow. What type of variation? Well, this is where I have to reflect back on how they are changing. So we said vessel length was increasing or going up, and the flow rate was going down. So they are moving opposite, which is inverse or indirect variation. And we know that for inverse or indirect variation, we're going to use division to set up our formula. So our last one says find the constant. And so in order to find that constant, I need an equation. And when we have data, the first column is x, the second is y. We always organize it that way. And I'm going to use f instead of y. F is the flow rate. I'm going to use L for x. X is the length. And I always write equations y equals, so I'm going to write this flow equals, excuse me, an unknown constant k divided by the length. And then in order to find the constant, I need to put in some values. So I can use any pair of numbers from off the chart. I typically use the first one. So the first one has flow rate of 90.8818, unknown k, divided by 10 is the length. To solve that, I'm going to multiply by 10 on both sides. And that will give me k equals 908.818. Excuse me. So now that I have the constant, I can use it to predict. And so it asked me to predict for a length of 60. So I'm using my formula. I know that flow is the constant 908.818 and divided by 60, which is the length. put that onto my calculator, and then I get an answer of 15.14696, but you can round somewhere. You don't need to keep all of those decimals. And so we have gone through the entire process here to model a variation problem. And what we did is we first observed in the data whether they were both increasing or whether one was going up and one was going down. In this case, one up, one down, that is the inverse or indirect, which gets modeled by division. When we set up the formula, the way the relationship works is that the data is always x and then y, and we write equations in the y equals format. So if you look at those generic equations in your notes for direct variation, you have the equation y is equal to k times x. And for inverse variation or indirect variation, you had the equation y equals k divided by x. And so since we're always writing y equals equations, that's why I started over here with the second column and said flow is equal to the constant, in this case, divided by length. And then we were able to do all the algebra from there, but those basic pieces, that understanding of what we should look for to find inverse variation and what the formula should look like, are pieces that we really need to commit to memory and understand how to make our model based on data.